This conference will now be recorded.
Right. So the objective of this class is to, we're going to cover up what is NoSQL and why NoSQL is database are required now when we have a sophisticated RDBMS products are already in the market. Why we are looking for different products when there is, RDBMS systems are already in place. What are the reasons we are going for NoSQL and what are the main benefits or RDBMS we have? So that also will be covered in detail. And NoSQL versus RDBMS. What are the main differences we do have in terms of terminology, in terms of technology wise? That also we'll talk about. Different types of NoSQL. So we do have different types of NoSQL databases. NoSQL, it's like SQL and NoSQL. In SQL family, we have SQL Server, Oracle Server, Postgres Server, MySQL Server. There are many like that. There are many SQL family products. Like that, NoSQL family products are also there are many, 20 plus products are there in the market. I'm going to give a little bit of idea about other products as well anyway. And SQL products, I mean RDBMS products will follow the ACID properties and NoSQL products will follow the base properties. What are the main difference between these two also? We are going to look at especially. So why we are actually looking at MongoDB especially, and not only MongoDB, NoSQL families, because of see nowadays data is a variety of data is getting generated from multiple sources. So people are actually, like if you look at, everybody has a mobile in their hand. Everybody has their, system. Almost everyone nowadays. So the sources of data generation became unmanageable. So RDBMS has a structured data where you have to, you have to define the structure, then it will feed the data. If you are trying to load some data which is not defined, it will not load. So NoSQL family is not like that. It is a flexible schema. It can pick up any kind of data. It can be structured data, unstructured data, semi-structured data, any kind of data the MongoDB or NoSQL family database can pick up. That's a major advantage why people are slowly moving to the NoSQL side, especially for analytical data. Anyway, I'm going to talk about all of that. So especially, why NoSQL database are required, because of variety of data is getting generated in the market. We cannot deal that with that data with RDBMS products, which is SQL especially. And the benefits and all we are going to see anyway. So here, NoSQL was introduced by Carl Stroji in 1998 to name his file-based database. Basically, this was introduced in 1998 itself, but there was no response from the market when that was introduced. The NoSQL family slowly getting adopted after 2010. Before that, there was no good footprint of these products in the market, especially after 2010. In between that, after that, data generation become very vast. It's like unmanageable. Like if you look at the social media data, log stream data, application logs data, and like structured, semi-structured, different sources of data we do have. The big problem with the RDBM system is it has to always be go with a structured manner only, where you are actually falling behind with the data requirement with the RDBM systems. And also, when it is comes to artificial intelligence reads lot of data in the background. So example, you're searching the YouTube. Okay, you're trying to watch the videos what you generally watch, your favorite channel, favorite like videos kind of. How YouTube is going to suggest you some kind of videos based on the analytical data. They are analyzing your like data what you're watching through your account, and they're giving some suggestions. How come there are lakhs of videos around the world, like in the YouTube, there's categories wise. If you look at, there is unlimited number of videos are there. Still, how it is able to analyze your pattern and give you some suggestions? So that amount of data, it cannot be analyzed with RDBMS. NoSQL is mandatory for this kind of data for sure all the time. So here, NoSQL represents a group of products and various related data concepts for storage and management of large data sets. So SQL especially is limited with the data. Like, if you talk about SQL architecture, especially let's talk about a little bit of architecture, then I'll move with the data. NoSQL benefits altogether. If at all you need to understand, if it is RDBM system, what happens basically in RDBM system? RDBM system, you'll have a one big server, okay, where you'll have a disks attached to it, and you keep storing the data. And if the disk is full, if the data is keep growing, what do you do? Basically, you'll extend the disk to accommodate the data. Okay, you'll extend the disk. If these disks are also growing bigger and bigger, you add some more drives and stripe the data to get the better IO performance. Good enough. But data, if it goes really abnormal, if it becomes enormous, so you cannot do the rebuilding indexes, because if it is a very, like if it is 100 TB database, if you're trying to do the rebuild will take days and days, where the business cannot afford to give that big window. So keeping that vast data in a single server is absolutely not going to scale. One server cannot scale up. So again, when you're going to process the data from one server, you have to give the computing power, like you have to add more and more CPUs, more and more RAM on the system, so that it can scale as expected anyway. But as you keep adding the CPUs and memory, you're going to pay really lot of money, because all RDBMS products are core based licensing model. How many CPUs are using in the machine, that many licenses you have to pay. So it becomes very, huge amount you have to pay to the product vendor. Okay, so when it comes to the again, you might be having the high availabilities in RDBM system. At any point of time, one can be writable, others can be there as a standby. Just you upload the data into one system, the other will be as a standby. In case of one goes down, other one will take up the data, which is fine. But at the same time, only one machine is writable. Maybe if you take about Oracle is a different story. You can use multiple machines for writes, but ultimately one storage at the end. All are attached to one file system at the end. So one source, one target where you're writing, though it could be SQL technology or Oracle technology, you don't have multiple areas where you can write data. That's the biggest drawback that is there in RDBM system. That's where you cannot handle the huge bulk data in the RDBM system. Artificial intelligence cannot work with the RDBMS for sure, because of the limitations on the product side. If you talk about NoSQL family, the architecture is different. Coming to that one, it is a distributed computing model. It's not like a vertical. This is a vertical computing model, we'll call it up. Vertical means in a single machine. Someone want to say something?
Ravinder, can we say this one as
Yeah, go ahead.
parallel processing method instead of
Parallel
parallel
processing, up to you,
processing?
like, yeah, you can NoSQL, you can say parallel processing anyway, but here also you can make a parallel processing by splitting the transaction into multi-threaded transactions. That is a different story. The processing of data by the machines, we are talking at the machine level, not at session level anyway. Yeah,
Mhm.
parallel you can say anyway. That word like applies here. But when it comes to the machine architecture, why just try to follow this. Yeah, you can say that parallel processing.
All
Parallel processing is also there on RDBMS, but you are hitting one source, one target. One target is the thing you see the difference with. If you look at no MongoDB or any RDB, any NoSQL family, they'll have this kind of architecture. You have one primary node, and all of its data will get replicated here. Okay, replica set. We'll call replica sets. We are going to configure in detail. No need to worry. If data, like whatever is writing here, it automatically replicate here and here and here. This is called replication technology. If one goes down, automatically other will take up. That is a traditional RDBMS technology. There is no difference here. But
right.
in case of, there is something called sharding. Sharding means, so you can add more and more servers like this. So here you can add multiple replica sets. I'm going to take everything in detail with all the real-time issues and all, but right now try to understand how the NoSQL families are like scalable and the capable of processing the huge amount of data in the background. So these are the replica set. Each is a data node, and every data node have its own replica set. And to process the data, we will have a config servers, config replica set. Config servers will have it. From the config, there will be router servers again. Okay, Okay, I'm going to explain this in the further anyway. Just I'm giving an idea before getting into the detail so that you get a clarity of about it. So that's why I wanted to discuss. This is something applications or somewhere someone is trying to talk. So let me make this architecture little clear. These are the users calling the applications. These are the mongoose, which are called your applications or where the applications can hit. And these are called the config servers. These are the routers, I would say. This is also a router, but it is a date where the data is exactly. Config servers will have a metadata of your data. These are the routers anyway, we can call it as. The first they'll hit the mongoose and mongoose will go and connect to the config server. These are the standby. If one config server goes down, other one will come online and then start pointing to where the data is sitting actually. So what exactly happened here in the NoSQL families? There are sharding. Data sharding will be range based and hash based sharding is there. So how do we define the range-based sharding, hash-based sharding? I'm going to show you practical anyway. We have a full implementation of it. But here, example, I'm defining some range. So 100 to 1 to 100 should go to this replica set, and 101 to 200 should go to this replica set, and 100 and 201 to 300 should go into this replica set. Single collection. Actually, we will call collection in the MongoDB technology, and in the RDBMS technology, we'll call it as a table. Table collection both are equivalent here. So just for the sake of discussion, I can say table if you are not familiar with the name. Okay, single table getting distributed into multiple replica sets. Each one is a replica set in the background. So you are sending the single table data into multiple replica sets. Each, see, if I'm sending example 300 rows, 300 rows are getting written into three nodes, and three nodes are responding in the background to write the data. So when you are writing into three nodes, definitely there will be writes will be striped out, where you get the good performance in terms of writes. When I'm reading the data also at the same time, three machines are responding at the same time. So like that, the processing will happen in the parallelly in different machines, not on the same machine. There are three writable machines here in this technology, in this model. If you look at, if the data is keep growing, assume a case that if the data is keep growing, because of NoSQL handles with a huge data, day by day data will keep growing on the systems. These will become, again unmanageable, right? So again, you start adding the another replica set at any point of time you audit, it will automatically balance the data. If you add one more replica set, you don't need to worry about it. Rebalances the data with all the replica sets within the sharding model. You don't need to do it. Just add the another replica set. It does the rebalancing of data, and it will offload the data from all the machines, and equally it will distribute to this replica set automatically in the background. So what you need to understand is we are getting the power in terms of machines here. We are getting the power in terms of machines. In RDBMS technology, we are getting the power in terms of CPU and memory on the same machine, which is growing vertical. This is called vertical computing. All RDBMS will follow the vertical computing model. These are the words we use it, vertical computing model. Whereas all NoSQL families will follow the horizontal computing model. Horizontal computing model. So if data is keep growing, and if it is trying, like if it is growing bigger and bigger, you keep add the replica sets so that data will get rebalanced and the data will be minimal on the each replica set. And whenever you're trying to pull out the data, multiple servers are keep responding to you, so there will be no delay at all, because multiple servers are keep responding to your request. It could be read, it could be write, whatever it is. All operations can be responded by multiple machines in the background, because each replica set has a different chunk of data. Example, I have 400 records in one table. So 1 to 100 here, 200 to 300, 1 to 100, 200 to 300, 300 to 400, 400 500, something like that. If I'm reading a range, where that range is sitting, the router server knows where the particular chunk of data exists, in which replica it will exist. This will point us to respective replica set, and it will pull the data automatically. If you're reading the data which is falling into multiple servers range, it will anyway contact that servers and get the data out of it. So RDBMS to NoSQL families, this is the this is the biggest advantage of this, like compared to replica set technology is almost similar to RDBMS. Like you keep one replica set, most of the environments will follow the replica set. Sharding is something not for all the projects will implement. Some critical data where data is vast, there will implement the sharding. I'll show the sharding in and out, no need to worry. In complete architecture, practical, how data is moving, how we can look at the chunk level data, how we can really balance if it is not balancing. Manually also we can do it. All of that we will implement in detail, but when the actual practical implementation starts, there I am going to talk about it. So the biggest advantage is distributed computing model. It is a distributed computing model means multiple servers are giving the request for a single request, multiple servers are doing the job and giving the data out of that. That's where in social media, if you look at, there will be billions of people are accessing the same site, still no one see that huge delay when loading the portal. And people also generate a very wide variety of data. Some people will load the video, some people will load the PDFs, photos, and any kind of, the NoSQL can pick up any kind of data. There is no restriction on any kind of data. It will just feed the data, whatever you are pushing it to the system. You don't need to define any structure. It is a schema-less and distributed computing model. These are the two words are very big when it comes to the NoSQL, especially. Okay, just that is the information. Let's go into it actually. See, what is NoSQL means? Not only SQL. The full form it is not only SQL is a new set of database, new set of databases that is not based on the relational database management system principles. See, in case of relational database model, how do you define a table? You'll define a table, you'll have a foreign key relationship. If at all you have a data dependency. In NoSQL family, there is no dependency. You can directly push all of its data into single collection, and within the collection you can re-refer the data. There is something called referential documents, embedded documents, that will replace the relational database referential integrities. That anyway we are going to see in the course. Schema design, how do we design the schema, how do we actually, as per the best standards, how do we define the schema? That is a third module I'm going to pick up there. What is a, if you define a structure, based on the structure you get the performance, good performance or bad performance. So the standards of schema design we are going to see in the third module anyway. Big data databases. So see here, if you talk about big data, I mean Hadoop especially, Hadoop deals with a vast volume of data. See, in NoSQL family, the famous one is big data first. Big data comes, in terms of market wise, in terms of revenue wise, the big data Hadoop is actually the famous at the moment. Right after the Hadoop, the Mongo is the next one, which is actually highly getting implemented in the market, because MongoDB is also fulfilling lots of use business cases. It is satisfying the lot of business use cases. That's where it is getting widely implemented in the market nowadays. Okay, that's one of the good thing to learn the MongoDB right now. And the next is, these are the third generation databases. These are dealing with a vast volume of data, and these are not like a simple like RDBMS. These are actually came with a different architecture. These are called as third generation databases because they are handling the very big volume of databases basically. Non-relational in nature. In case of RDB example, if it is a SQL server, assume case, just for the sake of discussion, just I have a SQL server. If I wanted to insert some data, first I need to create the structure. Okay, I'll just show it just for the example. If I have to first load the data into SQL database, I have to define the structure. Example, I want to define some customer data. Just assume a case. First, what I have to do, I have to clearly define the structure. Then I have to feed the data in that format of the structure only. So if I don't follow it, what happens basically? Just for the sake of discussion, I quickly do it. I'll show the Mongo as well how it works, so that you get the point what I'm trying to talk in the further slides. So just for the sake of discussion, I'm just doing this. Okay, something, whatever it is. This is enough. Custom. Okay, I created a structure table with the two columns in it. And if I'm trying to insert two columns, it will accept the data. Okay, it will accept the data if I'm trying to do two columns. If I'm trying to insert third column data, it does not accept. Why? Because that is what the nature of the RDBMS systems. You have to define the structure before enter that data. So if it is a NoSQL, it does not need anything. Every document, every row is independent there. That is called a schemaless. I'll explain in a bit. So I'm inserting some data. Insert into customer. Okay, values. So entering some record, it will pick up this data. Okay, because I defined two columns, it will accept this data. But if I'm trying to do third column data, third field data, whatever it is, so if I'm trying to do that, it will throw the error. What is error? Column name is invalid. So column name or the number of supplied values does not match the definition. So you already define some definition, some column structure, and you have to send the data which fit into that columns only. If it is not, it will not accept the all RDBMS products are like that. When it comes to NoSQL, this is a NoSQL. Let me show this. So this is a MongoDB product anyway. So show DBs. If I look at these are the databases I do have. I am just no need to worry about. I have installed MongoDB and how do we do all that. I'm going to take you through right from the scratch. No need to worry about. No prerequisite for this course. You just attend the classes regularly. You get to from the bottom to advanced level. I'll take you all of that. So example, I wanted to insert some data. So first to create a database in MongoDB, just use database name that will create the database automatically. So I'm going to create a database called class. Okay. So when the database is created, if you don't create any collection, does not display anyway. So db dot test is the collection name. It's not about the creating collections and all. We are going to see about the insert operation. That's the important part here. db dot test insert. I'm going to insert some data. So data will go in the JSON format, JavaScript notation. I'll make you understand in detail about it. How do you write the script? It's not a script, it's a structures only, no need to worry. So S number 1, S name, maybe Ranga, I'm defining it. And third one is, okay, I'll insert two fields, that's fine. Okay, what's the problem? It is saying I need to define this as name. Right. So now one row is inserted. How do I read that row? Test.find. If I read this, data looks like this. Okay. Now what I'm going to do, I'm going to insert one more record. Just sake of discussion, guys. You just need to understand. I'm going to call all of these discussions again in the further slide. That's why I wanted to make you see these things. You can easily understand further in the further classes. Second record I'm entering it. Name of is example Devendra. Okay, and his address is, I'll keep it address. See, this third column or field I did not like anywhere defined. I just straight away creating on the fly. It is accepted. If I read the data, see, first record, which is first row, is has a two columns, two fields, but third one has a three fields. The second one, if I'm going to insert one more, db dot test dot insert, different structure altogether. Just try to follow, simple. So third one, name, copy, and I'll keep it as location where he belong to. So no need to worry about this JSON format. I'm going to explain in detail. Everybody easily can catch it. That simple. So state where he belong to, something like that. Okay. It must be defined in quotes. In JSON format, it goes in the quotes only. Then city. What I wanted to show that MongoDB accept all sort of data. That's what I wanted to show here. So I'm inserting another record, which is again going with a different structure. db.test.find.pretty. Just I wanted to read the data in the proper format. We'll use the pretty. I'm going to explain all of that. If you look at, see, first record is having the two columns, two fields. We'll call it fields anyway. Second one has a three fields. Third one has three fields, but it has embedded document. This is called embedded document anyway. What is embedded document? How it is going to help us? How do we read the embedded documents is something further topic anyway. So what you need to understand is every row of this table, every document, we'll call it as a row, as a document, every document is independent. It doesn't need any structure. It just accept the data, whatever the type of data, whatever the format of the data, it doesn't matter. You just need like one collection. That's it. You need to define the collection. Test is a collection, and the data wherever I inserted, I mentioned test, test, test. The collection will be created on the fly. The collection also will be created on the fly. You don't need to create before you wanted to insert the data. Everything is automated. So the product does not actually reject any kind of data. You just need to see, nowadays businesses are very agile. Every day things are getting changed. To make it compatible with the customer requirement all the time, you have to change the structures of the application. Some applications are like that. So when you have to keep changing the application structure based on the customer demand, the rdbms, every time you have to alter and make the structure available, then modify the application, then feed the data. That is a lengthy operation. But if it is in NoSQL, you just modify whatever you wanted at the front end and submit the data. In the background, data will be accepted, and then it will record it in the system. So that is something, it is becoming famous because of these kind of acceptance by the product, especially. So non-relational, it doesn't have any relational, directly relational we don't have. It is something, if it is rdbms, you will fix the schema and you will have a fixed relationship between the table to table. If you insert in one table, automatically another table get populated, the child tables and all. In MongoDB, there is no direct relationship. Okay, we have a different kind of relation within the collection itself. Embedded document, reference documents, all that, we'll see it anyway. And these products will run on the commodity hardware, the cheapest hardware. You no need of having the sophisticated hardware like something from the Acer server architecture server, or IBM series, or Dell series, which is at server side. Those are very high costly servers. They are not cheap. Server side architecture is absolutely not cheap like our laptops. The server configuration will be, the complete CPU architecture and the memory what they deploy on the machines is a very different. It's not like our laptops, and they come with lots of charges. There will be there. That is not cheap at all. You have to spend a lot of money on the infrastructure itself. If it is a NoSQL family, it just runs on the desktop also. It doesn't need any sophisticated hardware. It just run on the normal computing machines as well, because you're distributing the data. The multiple machines are taking the load. There you don't need a sophistication of the hardware. Still it runs absolutely. And the commodity means the cheap hardware especially. So the biggest point for the NoSQL families, all NoSQL families have an open source. If we talk about MongoDB, we have two editions: community edition, enterprise edition. Community edition will support all features that you need for your business except monitoring, backup of your data. You have to take care. There is no inbuilt backup come with the product. You have to take the cron jobs and then pick up the data and keep it safe. That is your job. And monitoring, there is no monitoring. If one node goes down, you don't get the alert by the system, by Mongo, by default architecture. That should be, if it is enterprise, you'll get the MMS, okay, MongoDB management service, or else you'll get the ops manager, you'll get the Atlas. These three tools we have to maintain the enterprise versions. Especially they are compatible with the enterprise version. So these tools manage everything is automated. Just single click will do the automatic upgrade, all that. But community editions will also come with all the features that enterprise has. Most of the features, not all, most of the features, very close to the enterprise anyway. And you can run hundreds of machines under community edition. We have in the same, our environment have roughly 100 plus servers. Only 7 servers we have enterprise. The rest are all community editions, where you no need to pay single penny, absolutely free. So the biggest plus point for the NoSQL families are all of the products are open source. And they are open source means, if you take about any product, if you take about Oracle, MySQL is open source, it is free. But it does not scale with high data. That is, there are limitations on that product. But NoSQL is giving your data can scale up to any like any big data also it can manage. The community edition, still it is a cheap, and it is something open source, and where you don't need to pay anything. Still the version is capable of processing any big data, except few features are missing on that one. So that's how the NoSQL families are giving the like open source editions for market, so that people can easily adapt to this. And schemaless, no need to define the schema, it is on the fly, it is dynamic schema, we'll call it as dynamic. Dynamically it will create the object structure, it will automatically load the data into the system. You don't need to define before it has to load the data. Highly scalable. How you can say it is highly scalable? Because there are lots of systems are parallelly working for you to pull the data out of the systems. It is absolutely scalable. If example, if your data is keep growing, still the machines are 4 machines are parallelly working, it can scale. If it is a single RDBM system, you're keeping more and more resources on the system. If the table is getting bigger and bigger, if you try to do any kind of maintenance, it will get definitely have a huge maintenance window it will require, and that you definitely you cannot afford by the business. If you don't do that, your performance will be come down automatically, because you are not able to perform the regular maintenance like rebuilding indexes and update statistics, all that rearg indexes. If you cannot do it because of the table is vast and business is not ready to give that big window to maintain the indexes, you down the line you see the bad performance. It happens when you load everything into a single system, that happens. But here in the MongoDB, it's not like that. Irrespective of the data size, you can, your data is keep growing, keep adding the replica sets, that's it. It will scale with any amount of data. You just need to increase the number of server count. The data will get striped and automatically you get the data scaling, means the performance will be still, you get the good performance out of it.
Now I have a small doubt here. So it is
Yeah, go ahead.
worked in a distributed manner, right? Like if you insert the 400 records in a table, it will be distributed to like 100 to each and every machine. So
Right.
what about like if one machine fails or something, so that 100 records will be stuck, right? How can we manage those?
All right, good question. See, there are replica set again. For everything, there is a another standby machine. If this goes down, it is a fully automated function. It will pick up by the other node.
Okay.
This will become primary. It will have the all the data again. If a bad situation, as you said, all of the servers are went down. Assume a case, all of the servers. So MongoDB does not go down though one chunk completely down. It will operate with available data. It does not make the system down. Though one chunk is down, whatever the data is available on the other nodes, that will respond with that data, it will respond. But you may not
Okay.
get this data, but you get the data from this one. If it is urgent, if your data is fast, then you are gone. Generally,
Yes.
you keep it another high availability, that is a different story. High availabilities are there like always on. Always on will give the like storage redundancy. If it is a clustering, it does not give the storage redundancy. Even if it is Oracle, it's a rack concept. Multiple servers accept the writes, but ultimately going to one source, one target. If this is corrupted, there also there is no protection for data, right? Anyway, they'll keep one more redundancy, that is a different story. But here, the if example I have a database, one of the file is corrupted in the database, whole database will go down. It does not operate. But the NoSQL family, all of the systems will operate, though one chunk of data is gone. Still, it operates with the available data. That's another advantage. Okay.
Okay.
Yeah. Right. Highly scalable because the requests are getting processed by the multiple set of servers at the same time. That's where you get the good scalable performance. Highly available means even one machine is down, other machine is automatically, there is auto failover. We have auto failover anyway in this, so it will get auto failover. This node will become secondary, this will become primary, and it will keeps responding to this and start getting the load accepting the data from the config server, which is getting through the mongoose router server, and it will feeding the data. Meanwhile, if it is corrupted, if the data is like some data is missing, it is not synchronizing, how do we sync the data? That is comes in the replication issues. Anyway, there are lots of issues I'm going to discuss, all are live. What are the live issues we face, each technology wise, in and out, I'll talk about, because I'm working on this technology for more than 5 years now. I've seen lots of issues, lots of outages as well. So how do we resolve, how did we went through all the issues, how do we identify it, how did we fixed it? All of the experience I'm going to share during the class anyway, then when we start the modules, the respective modules anyway. Supports base properties instead of asset properties. Base is a different story actually. Basically available, soft. What it is a full form? I'm not sure. Just I forgot about it. There is a full form for it. I just Right. Basically available soft state eventual consistency. By default, what Microsoft will follow is what Mongo will follow is, see, there are right concerns. We have right concerns. Based on the right concern, you have to define it. But by default, it is not a right concern, right replica concern. Basically, we have a memory acknowledged in right concern, and like we have oplog acknowledged model and replica acknowledged. So there are multiple layers we have. So by default nature is, if I modify something here, it will record in the oplog. Oplog will automatically ship it to the standby secondaries, and then it will update there. If I update something here, it does not reflect here immediately. It takes some time. It is eventually, it will make the data consistent across the other copies. See, we can read the secondaries for the reporting. It is possible to read the secondaries directly from the background. We can read it. How do we read it? We are going to see that in the further when I start the modules. We can read this to get the data. Whenever you're reading it, whatever the data is written to here, it is not immediately available here based on the network, based on the machine capability. It will sync up with this one. There could be delay. It is asynchronous by nature. Asynchronous means eventually the data will be available in the standby nodes eventually, not immediately. So we can make it immediately as well. That something comes through the transaction. They'll have to mention right concern should be replica set concern. There should be something. We will set the property set transaction level. How do we set each kind of properties? We will explain. I will explain when I start the replication module. No need to worry. But anyway, this will follow the basically available soft state eventuality means eventually data will be available on the secondary nodes, not immediately. Mostly runs on the cluster environment. See, the NoSQL have a good architecture. If you are using the sharding, it will give the best benefits. Okay, if you are using the sharding technology, you get the best benefits. If you are just using the replica set, one copy will only be again writable, others are readable only. Anyway, you cannot write into the secondaries. They are the standby copies. If you're using the sharding only, you're going to get the good architecture. Like you're going to get the advantage of this technology. If you're not using it, again, it's like a traditional RDBMS system. Like I mean, data protection wise, it is like a traditional RDBMS system. One will be writable, others will be just a standby in case of primary goes down. The same thing. So if you go with this sharding clustered basis kind of architecture, you're going to get the good benefit or from this product especially. This kind of architecture is not there in any of the RDBMS system. No RDBMS system is giving this parallel processing of writing data. Especially reading can happen. You can do that. Reading is also one node data. Multiple does not accepted by the RDBMS system. One secondary copy, if you're reading one from one copy, you can read it, but you cannot jointly route the traffic to the two machines and get the combination of that, and reading is not possible in the RDBMS system. Here only it is possible in the NoSQL family. Scaling is good in this product especially, and built for new generation applications. New generation means where vast data is actually need to be processed through the sorry, through the application. There this product is getting used nowadays. Right. Why NoSQL? Basically, again, it's kind of, the same discussion what we have done, but slowly we will get to the right points slowly. See, resolves the challenges, faced in storing, managing, analyzing, and archiving the data. So especially when the data is like a streaming data, maybe social media data, application logs data, a semi-structured data, unstructured data, the RDBMS product cannot deal with the unstructured data. It should be structured only. Always you have to define a structure, then only it can take the data. That is called a structured, predefined structure of data. So the unstructured, semi-structured, and where data doesn't, you don't know what kind of data people are going to push it. If you don't know the what kind of data it could be structured, unstructured, you don't know, then you cannot use RDBMS. It must be NoSQL only. And explosion of social media data like Facebook, Twitter with the large data needs. So all social media platforms are using the NoSQL family only in the background. That's how they are scaling up. Billions of people are hitting the the social media platform, still they are giving the response. Billions of people can hit the system at a time and they can get the response. That's how it can scale. If it is RDBM system, it absolutely chokes at one point, and it will absolutely get the, like you need to reboot the system or something, you have to do it to get into the normal state. So NoSQL is not like that. It can take any amount of load, any amount of users can hit the system parallelly, still it processes data, because there are hundreds of servers are working on your request, not one. Need of continuous availability. Of course, you need a continuous availability in social networking or anything. Like if I'm example trying to buy something, example in the e-commerce business, it will show my interested data. Why? See, if I'm buying one product now, next time I log in, it will give me some recommendations. Okay, you are trying to bought this kind of products before. Now maybe you might see there will be recommendations. That kind of recommendation, artificial intelligence, is possible through NoSQL family systems only, because there is a huge data. There will be uncounted number of customers are there. You cannot count in e-commerce business. There every day people are registering with your website and doing the business. You cannot track them everyone with the RDBM system. The intelligence system work with the vast variety of data. You have to collect lots of data. Search engine, what you are searching it, what you are buying it, what your interest, all of the data they have to collect it, and then analyze all the data and give you some suggestions on top of that. So this processing will take lots of data to, in the background, to analyze it. So to analyze that kind of thing, one system cannot do it. That is something done by the NoSQL family only. Need of more flexible data model. See, everything is agile nowadays. Everything agile means on the spot people are giving the different requirement. If they are giving the different requirement, you have to, if you are build some application already with certain fields, you need extra fields, you need to define the structure again, do it. But I don't want to do that, because my business is all the time agile. Every time I'm getting the new requirement, new challenges for my business, I have to face it. So then RDBMS is not going to work in that direction. It has to be always fixed. You have to define, then only it will accept the data. But NoSQL is not. It is always flexible schema. The NoSQL database is great solution for growing scale of databases and falling prices of commodity hardware. Slowly, as many competitors are coming, manufacturers are coming, the storage point of view. See, olden days the storage used to be very costly. If you buy a pen drive, what was the cost when we were, tens and intermediate standard? The pen drive cost was very high. Now you pay 400 rupees, you'll get the 8 GB charge, 8 GB pen drive. So the storage cost is slowly, gradually reducing, right? When many manufacturers are coming in the market, the storage cost computing model is also slowly coming down. Okay, so kind of, you are able to get the infrastructure at lower cost. The commodity hardware you're getting at lower cost, you can operate your business at lower cost, so you can save the money. Ultimately, everybody looking for saving the money, right? Everybody does the business not for the charity. At the end, they wanted to project the good results so that they can get the good share price and they can get the good profits to the company, so that they can grow further, right? So for that, they have to save the money in all directions. So now MongoDB is giving the all type of scope for saving the money, because if it's open source and it can run on commodity hardware. It is a schemaless, like a dynamic schema. It is kind of a dynamic schema product. So dynamically you can, no need to define it, dynamically pick up the collection name, it will insert. See, when I was inserting some data, I did not create the test. Still it'll create it. If example, if I'm trying to show collections, there is a command called show collection. How many collections we have here? Only one collection. What I'm going to do, db class dot insert. I'm just trying to insert some data, but I did not created the class collection yet. I'm just inserting one row. It is still accept. If I go to here, show collections, it is created the collection name all dynamically. You did not create this. It is created on the fly. Absolutely. So this is called dynamic schema allocation. You just feed it the data, the format, what it accepts, just it does everything for you in the background. No need to worry about it. If it is RDBM system, it doesn't accept data like that. You have to define it before you do it. That's something is different from the RDBMS product. Consists of column-based data stores, key value pair data stores, and document-based. So there are different, like NoSQL family technology stack products. Each one is handling different area. What are those? I'm going to explain a little further slides anyway. I'm going to talk about it. No need to worry, because NoSQL is not only MongoDB. MongoDB is one of the product in the NoSQL family. Like if you talk about Cassandra, MongoDB, Couchbase, DocumentDB, Big Data, and MariaDB and DocumentDB, there are different products we have in the market. If you name it, there are lots of products are there, and everyone are handling different areas especially. But anyway, MongoDB is actually serving lots of use cases which are required by the business. That's where this is getting implemented on getting implemented on kind of market is adopting this product because of it is like fulfilling their requirement in many directions. So after Hadoop, the MongoDB comes in the next line in terms of implementation wise, in terms of revenue wise, that is generating in the market. Offers capabilities to handle large volume of data using various available features. There are a lot of features anyway. There are a lot of features about replication as well as sharding. These are the main technologies in the MongoDB, especially for high availabilities. There are many features on the standalone as well. We are going to see that anyway. Right. It's kind of recap, guys, quickly. So the benefits of NoSQL: continuous availability, no single point of failure. If it is something RDBM system, if one server goes down, if one server goes down, your data is corrupted in some case. Even if it is always on, even if it is a clustering, your data is corrupted. The corrupted data will migrate here anyway. The secondary one also will be corrupted because corrupted data itself is migrated there. It happens, there is no data protection at hardware level in any of the technology if it is corrupted physically. So if that happens, single point of failure, the whole system will be down. If it is a NoSQL family, though one replica set is completely down, still you are operational. There is no downtime. It is still data. Whatever the data is, like available in other nodes, you still can operate. I'm going to show this. I'm going to bring down one replica set. Still, we can read the data, whatever is available from the backend servers. We're going to see that practically anyway. We have all of that discussion. Multi-data center capability. This is another big advantage. What exactly multi-data center capability means? One you can run in one data center, one you can run in another data center, one you can run in the cloud. I'm going to show how do we migrate the data from on-prem to cloud without any downtime. Migrations are also I'm going to cover in detail, all sort of migrations, upgradations, everything I'm going to cover. We are going to see in detail of it. How do we migrate, how do we upgrade? What is upgrade process? What is a migration process? So if you wanted to migrate to on-premise to cloud without a downtime, we can migrate through the replica set. How do we migrate without a downtime? That we'll see. How do we migrate a server from like one version to another version in the rolling fashion or standalone direct method also? We will see all of that. We have all the concepts anyway. Right. Easy replication for distributed location independent capabilities. See, when it compares to the RDBM system, the configurations are quite simple. Quite few commands will do everything. Just few sequence of commands will do everything for you. But if it is RDBMS, the technologies are complex. It's not straightforward. You have to do a lot of things. If it breaks out also, you have to do a lot of things to fix it. MongoDB have straightforward solutions. We have very easy solutions. I'm going to explain all of that anyway. What are the solutions? Easy, how we can easily do things to fix it kind of. We're going to see that anyway. But MongoDB is giving easy of configuration. If you wanted to configure replication, you just need 3 commands. It does everything in the background for you. If you need the sharding, there will be a little bit of complex, but I'm going to take you through step by step. That something is little complicated. It's not complicated, little. I mean, I'm going to tell you the step by step. You can easily catch it. Everybody can do it. No need to worry about that. High performance with a linear horizontal scalability. This again, horizontal scalability means multiple servers are doing the same, serving the single connection to pull out the data where you can get the good performance. Flexible schema support, easy to implement and maintain and grow, especially you don't see too many issues in MongoDB, especially in terms of performance, in terms of downtimes. You don't see, it is a very stable product. What are the, once the product is stabilized, you don't have too much of work. What do you do basically? You have to monitor the space, especially space. Why? Because NoSQL family will deal with a huge volume of data. So whatever the disk space you allocate in the next over a time, 1 month, 2 months, 3 months, your storage mostly will occupy. So you have to keep an eye on the, especially on the storage side. Other than that, you work on the regular operations like creating databases, creating the collections, moving the databases here and there, creating the users, giving the permissions, very generic operations. Because of MongoDB has a lot of inbuilt functionalities which will take care of all the things. The application will protect in all directions anyway. There is a simple methodology to fix the issues as well, even if you face any issues. Uh, Someone have a question? Okay. Thriving open source community. See, every NoSQL family product, any product you take it, every product has a open source editions, and that will be, is not like limitations. There are no limitations. It can give you all core functionality of the product, but they will keep some cutoff in terms of support. See, if I use only community edition, assume a case, I cannot get the support from the Microsoft MongoDB directly. You cannot, you have to pay for it. You have to take the paid support model. If you have to take it, if you buy the enterprise, which is a licensing model, you are paying for the licensing, they'll give you the free support. Either you pay for the support through the community edition where you are avoiding the licensing, or else you pay for the licensing, they'll give the free support. Either way of it, you have to follow either way of it. So anyway, you are see, if you take it RDBMS licensing costs are very high when you compare to the NoSQL. And every RDBM system now charging at vCore model. How many CPU vCores you are using on the machine, that many licensing costs will apply to you. But in NoSQL, it's not like that. It's a machine level. How many CPUs you wanted to keep it, doesn't matter. How many machines you are using it for the technology, that will be a chargeable here. There you can save a lot of money. See, if you are paying 100%, example 100 rupees for the um, what I would say for the RDBM system, you might pay 40%, 60% straight away. You can get the benefit out of this licensing model, because NoSQL enterprise license are also cheap compared to the RDBMS license model. If you take it Oracle, SQL, they're costly too. Oracle is damn costly. SQL is somewhat okay, but Oracle damn costly, the licensing wise. You cannot get a cheaper price. They charge a lot. If you run one Oracle server, Mongo, you can run 20, 50 servers also. It all matters, how many, how big your Oracle server, how many cores you are using, all matters anyway. But RDBMS system licensing is not cheap, very costly. When it comes to NoSQL will give you the flexible, they are giving you the open source where you can use all the options, all the features almost, except a few encryption. If you don't use enterprise, you cannot do the encryption. Data encryption is not supported, especially. And you cannot do the automatic monitoring of the services or servers automatic. If you take it in Atlas, data, the disk also will grow automatically. Atlas is something cloud-based deployment. It runs on top of the MongoDB. Actually, it's a everything is a MongoDB tool. There is no third-party. Ops Manager is also MongoDB tool. MMS is also MongoDB tool. And if you talk about Atlas is also MongoDB tool. So everything is Mongo. What they are, giving enterprise level tools, their tools. If you talk about Hadoop is actually open source, which was developed by the Apache. Apache is given that product into the market at free of cost, as open source, and that open source picked up by the Hortonworks, okay, Cloudera, and two different people. They developed their own part and selling into the market. If you talk about Hadoop big data, they have two distributions. You have it. One is a Cloudera, one is Hortonworks, right? There are two distributions, and open source is actually given by the Apache. But in the MongoDB, there is no such involvement. Everything is a MongoDB. Community edition, enterprise edition, the core product is completely owned by MongoDB. There is no third-party person is involved into this product development. Completely MongoDB everywhere. All tools and all, they are giving it anyway. Okay. Right. Let's compare a little bit of it. So RDBMS product will follow the rigid fixed schema. You have to define the schema, and that is what it is exactly. If you don't follow the schema model, what you define, you don't accept the data. It is dynamic schema. You just just give us just one collection and enter the data whatever you wanted to enter. It will just accept the data. It doesn't reject any kind of data, any structured data. It can be structured, unstructured, any kind of data it will accept. Semi-structured data, whatever it is. This will follow the vertical scaling. Vertical means one machine. Within one machine only, you giving the resources to one machine, it will keep scaling with that single machine itself. You cannot keep multiple machines for write operations or parallel operations. Here is horizontal. Multiple machines can do it. We have discussed that anyway. Difficult to handle big data, vast data. You cannot handle with these systems, RDBM systems, like where you are generating the structured, unstructured, even structured data also. If it is growing abnormally, you cannot handle with RDBMS. It's very, very tough. When the data goes into TBs and TBs data every month you are generating, the maintenance you cannot do it. Maintenance in terms of indexing, rebuilding indexing, reorganizing indexing, and structures of the data types. If you don't follow few things, RDBMS is going to screw up with in terms of performance. Okay, you need to follow all the standards, then only it will scale a little with the vast data. If you don't follow it, you're gone. That's not good for the vast data. Can handle any big amount of data, zettabytes of data. Zettabyte means very big amount of data. It can handle anyway. Mix of open source and proprietary, and it is absolutely open source. Every product has open source. Enterprise edition anyway MongoDB has, that is a licensed edition where you have to pay. But standard edition, it is absolutely like you can handle any big data on the community edition also. There is no limitation in terms of handling data. There is a limitation in terms of features, encryption, automated backups through the product, or automated monitoring. That few things are missing, but the rest of the thing, core functionality is given. All the functionality is given. They did not cut off the resource level, utilization level, which is good. Mostly standalone, mostly clustered. Clustered will give a good performance. These are all standalones are clustered. Whatever it is, one will be the at any point of time can accept the right operations. Single point of failure, if one goes down, you might see the downtime, but here you don't see the downtime. Multiple machines are doing the job. Even if one node goes down, other node will come, the active node, it will pick up the data automatically. You have the node level redundancy. You have the node level redundancy as well as at cluster level. If you look at, all the servers are giving the response. So you have the availability wise, it is giving you more availability than the RDBMS, availability wise and performance wise. Okay, these two are major points for any product. Availability and scalability is very important. If you compare with RDBMS, the NoSQL is giving the best availability and scalability than the RDBMS in terms of data processing. Right, ACID properties and base properties. That's something. ACID properties are obeyed by the all RDBM system. Base property are obeyed by the NoSQL. All NoSQL will follow the base property. Need server class hardware. You need sophisticated hardware to run this product. You need like a IBM server series hardware, or Acer or Dell. There are lots of products who vendors like manufacturing that is a very costly hardware. It's not cheap. This can be run any hardware. Even you can get the desktop from the market, you can run there. There is no such restriction. Okay, even one server is get crashed, other one is still holding the data. One server, one machine is going down, you're not going out of data. It is very costly to implement these products. It is average compared to this one. It is average, like you might save 60 to 50% of the charge when you use this one on the enterprise, complete enterprise. Still you are running what you are using the RDBMS, still you have 50%, more than 50% you can save comparatively licensing cost wise. Okay, and if you look at, I said there are lots of different types of NoSQL family products are there. Key value pair, document based, column based, graph based. So if you look at here, Redis server, Memcached, Scalaries, and document based MongoDB, CouchDB, RavenDB, Bigtable, Cassandra, HBase, Hypertable, Infinite Graph, FlogDB. These are the products. They are there in the NoSQL family, and they are working a different methodology. Key value pair. It is something, if you mention the key and value, you can get the record based on that. Document DB is something MongoDB anyway. This is something you don't need to worry about. We are going to talk about Mongo. Rest of the things we are not going to touch base anyway. But these are the product and these are the different categories we have in the NoSQL family. Right. So introduction to big data, especially big data, what exactly it is going to give, what kind of benefits you are going to get. Big data is any data that can be handled and processed through the traditional systems. Traditional means commodity hardware. It's not something high level, high class server configurations or server hardware. You don't need it. Big data involves millions of users. Millions of users can connect the system and do the job at a time. Millions of queries per second it can execute in the background because lots of server doing the job. Billions of data can be processed at the same time. Multiple people are doing the insert, update, delete and reading simultaneously in the background. Still it accepts all sort of requests. It's not one system is working for you. There are lots of systems are working for you. That's why you can still handle it. See, if you talk about Facebook does not give will not have outages. You never see that Facebook is not landing at all the time. Because they have such availability through the NoSQL product only. And what data you're feeding to the portal in the Facebook is actually it's not structured. You might upload one video what you recorded, you might upload PDFs, photos. Every media is different, everything is different, right? It is still accepting all sort of data. See, nowadays data sources are vast. It's not something before these systems are softwares are developed, people used to do the lot of paperwork. Paperwork was enough that time. Why? Because there was no much of data they were used to be generated. After that, the Oracle came into the picture 1970s, and there they used to handle the data. Before Oracle, there used to be Excel data, Word data they used to maintain. But when the RDBMS came into picture, then RDBMS they started using it. That absolutely fine to handle the data that time. The data sources are very less. Someone has to sit at the system, enter the data. That's how it used to happen. Now everyone has a mobile, everyone has a different devices where they are generating the data, and that data is also not same kind of data, different data. And all these data people are whatever they are generating is becoming the unmanageable data. That unmanageable data cannot be handled with the RDBM system. It can be handled with the NoSQL family only. This is where we are getting the demand for the NoSQL in the market. That's why we need to learn. Anyway, it's a ongoing trend. Maybe in the future RDBMS products implementation become less and the NoSQL family products will take the higher implementation part in the market, because they are closely giving all the features what my RDBMS is giving. They are trying to make all the features that RDBMS is giving in the NoSQL family also. If that it is on the journey anyway, down the line they are going to achieve that. If they achieve that one, RDBMS products will not have any value if they are giving, if you are going to achieve all of that. Anyway, asset properties, MongoDB is already introduced in 4.2. You can do the asset properties. What is asset properties? I'm going to explain the next slide. Anyway, so a variety of activities at the same time you can do it. Insert, delete, update, read, all you can do simultaneously. A variety of actions at the same time. The big data, especially big data properties of volume of data, have a huge volume of data it can process, variety of data, like different types of data it can handle, and it will give the good speed. 3 V's we'll call it: a volume, velocity, like a variety of data can be. These three are the major components of advantages of the NoSQL family systems anyway. Right. If it is a vertical scaling to the RDBMS system, if it is RDBMS system, you keep increase the RAM into single machine, CPUs into single machines, increase the space into single machine. Then it will give you more and more cost, or keep adding the hardware resources like CPU, more CPUs, more billing, right? Downtime. It is a standalone, so single point of failure that can bring you the more downtime. Threshold and limitations. If you talk about SQL Server can accept maximum 65,000 connections simultaneously. If it is going beyond that, it will not work. You cannot open more than 65,000 sessions on top of it. On Oracle, I'm not sure anyway, but there is a limitation. RDBMS for NoSQL, there is no limitation. It can hit millions of sessions at the same time. Single point of failure. Of course, if one server goes down, you'll go out of data. And it's horizontal scaling. See, that is what I was explaining anyway here. Horizontal scale means each one is one replica. Each one is one replica. If one data node, these are called data nodes. If one data node goes down, other data node will become a primary. It will keep responding to the config server, and config server will send the data to automatically to available primary node. It's like that. Add more machines to get the more performance, more scalability, more data distribution. All will happen through more machines. Less cost because it runs on the commodity hardware. No much downtime required here. At rolling fashion, whatever you do, we will do on the rolling fashion. How do we do it? I'm going to explain, no need to worry. The maintenance and all we'll see.
One small data here. The standby machines, standby nodes are there, right?
Mhm.
Like the second one. So will they supply any read requests? Like,
Yes, you can read it if at all you want it from the background. You can use these nodes for the read purpose.
so, but like if any user requesting a read something, so first which node it will hit? Like the primary nodes it will hit or standby only? Like is there
No,
any
no, primary. By default, primary.
routing?
If you go coming through the application which is hitting the Mongo will hit the config. Config will take you to the
There is no kind of routing. Okay.
routing. You have to, if you are reading the data, you have to hit the secondaries manually.
Okay.
You have to hit it. There is no routing directly to the read copies. It will take you to only the primary copies, the router servers. These are
Okay.
backend. That's the architecture. Anyway, how do we read it from here? I'm going to show that. We have the concept.
Okay.
So can be scaled down, like it can scale at any point of time by adding the more and more machines where you can process more data. Right. This is what I was talking about. What is asset properties? What is a base model basically? So atomicity says that this property is obeyed by the RDBMS systems. It must be followed by each and every RDBMS system. Atomicity means either a batch. If you're running the begin tran, I'm running the batch file. If it fail in between, it will roll back completely. If it is finished, it will apply all the data back to the system, but it never keep the batch in between. It will definitely either keep all the data rollback status, or else it will keep in the roll forward status. It does not keep anything in off done status. It will absolutely make the data consistent. Consistent atomicity, almost similar words anyway. Consistency makes sure that data will always be either committed or rolled back. Rolled back, either failed means rolled back in between if it fails. If it is committed, not applied to database because of abrupt system shutdown, it will apply once it comes online. So atomicity will take care that it will make sure that transaction should be either committed or rolled back, and the consistency will make sure that okay, data if the system is abruptly restarted, it look for that what transactions are actually not applied. It will look at the log, it will verify it, and if it is committed, it will apply back to database. If it is not committed, it will roll back anyway. Isolation means one at a time. If I'm trying to do one transaction on the table will be locked for you if you're writing it. Read can be, n number of people can read parallelly, but write operations definitely one at a time. If multiple are allowed to write on the same object on the same row, there will be data inconsistencies will get created. So write operations, all modifications should be isolated one at a time, not all parallelly on any of the RDBM system. Durability means your data will be permanent. Once it is applied in the system in the background, the data will never change on its own. As long as you're not changing it, data will never change. Once it is written, means written. It won't change the data on its own. It will be exactly the same what it was. So it will look at the data what you have in the system. It will keep maintain that data, does not modify the data on its own anyway. So this is something NoSQL is basically available soft state eventuality. You can read in the reverse order, this one especially. Eventually consistent. See, by default architecture of MongoDB is you can whatever you're writing it will write in the op log will migrate to the secondaries will sync in the background automatically. It's not, it can take 60 seconds delay, depends on the network, depends on basically it can be 60 seconds, it can be longer than that also if you don't have proper network between the nodes. But eventually data will be reached secondaries if both are up and running. If it is down, data gap will be there, that is a different story. But whatever the data you are generating, it eventually it will get updated in the other copies of your replication. That's what eventuality means. Right. MongoDB initially developed by Tengen. Tengen itself is MongoDB anyway. They changed the name. Roughly it was 2006 something. I'm not sure which year they have changed. But originally the MongoDB company name was Tengen. When they developed it, they used to call it a document database basically. Now they turned into MongoDB Incorporation. Okay. The MongoDB Incorporation is the owner of MongoDB. No one, there is no distribution of MongoDB. The complete enterprise edition, community edition, both are distributed and given owned by the MongoDB Incorporation only. There is no third party involvement into this product right now at product level. I'm talking about. So only these guys are giving that product. It's not something like Hadoop. If you think about Hadoop, there are two distributions. Apache is given and developed the Hadoop product, but someone has Cloudera and Hortonworks. They are two different bodies again. They picked up that open source, they developed in their own direction, they're selling it to the market. So, but the original owner is Apache of that Hadoop. But here, no one is original, no one is involved in here. Completely owned by the MongoDB itself. They developed it, they are selling it right now in the market. No one is as a partner is there. So it is object structure document stored in the collections. Each object has a primary key called object ID. This object ID, we have a complete discussion. Object ID will tell you when the data was last modified in the collection, when it was modified. It will give you a lot of details. By default, you'll get the object ID. If you don't want the object ID, you can avoid that also. Okay, we're going to talk about this. This is very important for us when we troubleshoot. Who is at what last modified document, when the last modified row, you can identify using the object ID. We can do a lot of troubleshooting based on the object ID. This is very important for us. I'm going to take off class on this one, not off class, maybe I'll spend good amount of time. This is very important for us to understand what is Mongo object ID, how it is going to help us to troubleshoot a lot of things. Replication also, this will help us to identify certain things. We're going to see this anyway. Manipulations with the objects in the collections. Find objects or objects via simple selections and logical expressions. Update. Anyway, this is something like MongoDB can support all sort of operations which are called crude operations. So you can do the create, drop, read and delete as well. You do all the operations that you do in the RDBMS, but in the Mongo you don't have rollback process. There is no, even you write a batch file, if I'm trying to execute a batch file from thousand records I wanted to enter resume case, the session is ended at 500th record, so 500 will be inserted and they will be applied to the system. There is no, if it is failed at 500th row, it does not roll back. There is no rollback process in MongoDB. Everything is implicit commit, means by default it applies the commit. So if something is failed, till what record it has executed and how many records are executed and applied, you have to verify, you have to run the rest of the records. If it is RDBM system, if you run a batch file, if it fails in between, when the database come online, it will roll back because batch is not finished. The rollback process is not available in the NoSQL, any of the NoSQL family. There is no rollback. Directly, everything has an implicit commit statement. Implicit means indirectly, you're not supplying the commit, but it is by default commit. You write it means write, that's it. If it is written, it is done. There is no rollback. You guys are following?
Yes, Anna. So, small doubt, Anna, here. Like, if any transaction have like cancelled in between, so whatever the transactions are applied, for example, 100 transactions are there, 50 are applied, 50 not applied. So, if we run the transaction again, so it will start from the starting, like from 1 to
Yes.
100 again.
You have
So
to
there
keep the
will be,
no, you have to
okay.
keep the conditions.
Okay, so in case we cannot keep, there will be a duplicate records will also be there, right? Like,
Actually, you have to define the column level restrictions. Don't accept the duplicates. There it will fail. You can
okay,
give it, you can impose the conditions. That is what called schema design, third module. How do you define the schema so that that kind of mistakes won't happen?
acha, okay.
We have third module. I'm going to talk about that. You can restrict certain like conditions. Based on the condition only, it will accept the data. I mean, on that particular column, like you said, five, like 50 records are inserted. If I rerun again, 50 records are inserted, it will become a duplicate. but I don't want such thing. I want you to impose certain conditions so that it will verify, okay, this is trying to reinsert the same data, what it is there, it will fail there itself, does not accept the same data.
Okay, so we need to impose that constraint, or by default it will be there, like how it will be?
No default. We had to come up with our own logic. I'm going to tell all of that in the third module.
Sure.
We have all of
Thank
that. No need to see. For this course, there is no prerequisite. Just be regular to the class. You will walk away. Absolutely, I'll guarantee that you will walk away with advanced knowledge. I'm going to cover 10 modules here, not 10, actually 11. See here, introduction to this is not yet over. The instruction will cover the installation as well. Basic administration, architecture, internal, external architecture, logical, physical architecture, complete architecture. The architecture plays very bigger role. So I'm going to talk about complete MongoDB architecture, how exactly it will handle the data in the background. We can see it actually. I'm going to show all of that. Crude operations, schema design. This is a fifth module, what I was saying actually. Indexes, performance tuning in the MongoDB. That comes in the indexing anyway. Administration commands means all standalone servers. How do you manage all standalone Mongo instances without replica set? Backup and security. How do you take the automated backups? What kind of security policies you have? How do you create the users? How do you give the permissions at server level, database level? All that will be covered. Replication, replica set. It's something not only configuration. I'm going to talk about lot of issues that I faced throughout my career. I have prepared, step by step process for it. I'm going to discuss case by cases. I'll send the documents as well anyway. Scalability is called as sharding anyway, indirectly. Sharding. Sharding also we are going to configure in detail, and I'm going to talk about it. And we are going to see the lot of troubleshooting, guys. Configuration in the MongoDB that simple. Few commands will do the everything. It's not big deal. The big deal is to understand the architecture of that technology in the background, and how do you respond to the issues, how do you troubleshoot. All that will be covered. So how many of you are from the Linux background in the class? Let me 1 minute. Anybody have question what I have discussed so far? Then I'll talk a few questions. I wanted to ask
Yeah,
3 questions.
I have one question. So
Yeah, go ahead.
while in shading, while reading the data, it will use the multiple node, right? While writing, update and delete also, it will do the same.
Yes, for all operations multiple, because see, if I'm writing 1 to 100 is there here, I'm trying to update this 1 to 100, it has to go to that only. Here 200 to 300, 300 to 400. So for all operations, all nodes are responding.
Okay, so we need to modify the query based on this, or automatically it will do the.
It is automatic. You have to
Okay,
define the table level. We have a range-based sharding and
okay,
hash-based sharding. The
okay.
technology, what you define, that will take care. No need to do anything.
Because in our structure SAP IQ RDBMS, na, so we are defining at the query level so that the multiple node can read the can process the data with the range partition and all these heads partition like that. So I am asking the same.
If it is partitioned into the MongoDB, you no need to mention anything. It has already partitioned, means already scattered the data into all the nodes.
Okay.
So what you are reading, where the data is there in different
Hmm.
machines. So all machines will respond to you.
Okay. Okay. Thanks.
Yeah, you're welcome anyway. So any other questions before I stop it? I wanted to talk a few things. Anyone have any question? Let me know.
So Ravindra, we need Linux to learn the MongoDB, because I'm not from a Linux background.
Right, that's what I'm going to ask. Actually, Linux, next 2.5 sessions are Linux, completely Linux. How do you interact with the Linux? What are the basic commands we do have? Complete Linux administration, we need to know as a MongoDB. DBA. I'm going to cover 2.5 sessions in detail, like security in the Linux model, file system management in the Linux, all the basic commands. How do we browse through the, like how do we create the users? How do we add the users into the groups? How do we take the ownership on the file level? How do we move the files between the Linux machine to Linux machine? And all the basics. As a see, you don't need to be expertise at OS level, but you need to have some knowledge on the Linux area so that you can manage the product. So what level of knowledge you need, all level I'll cover up. Then I'll start the product. No need to worry about most of the people are from non-Linux. I can understand. you come with the zero knowledge, I'll make you understand about the all Linux commands, what you need to know for sure.
So did you say only two sessions for the Linux, right?
2.5 it can
Okay.
be, but I'll cover all of that. I have the document as well. I'll take the document, I'll explain you in detail all of the commands which are required for us. Right, any other questions, guys?
What about JavaScript knowledge?
No need to worry, I'm going to cover right from the how do we write right from the elementary to advanced level. If you look at the script, you need to understand what the script is doing. JavaScript, the JSON format scripts, it is very easy, dead easy. I'm going to run through the proper way so that you can easily understand the JSON scripts. Dead simple it is. Anyone can learn. There is no background required, like you don't need to be Java developer. It's dead simple programming language. I'm going to make you understand in detail of it. That is my guarantee. No need to worry. I don't run into like any hurry burry kind of. It must be delivered properly. Everybody are understanding. Then only I'll move forward. I'm okay with a few classes extended. The motto of the lecture is to everybody receive things what I'm trying to teach you.
Like, do we have any like any sessions for that as well, like Linux?
Can you come again? I didn't catch your question.
Do we have any like how many sessions for the JavaScript, like Linux? We would like 2 sessions for that.
We have I guess 2.5 sessions for that as well. No need to worry. It's not fixed. As people are keep asking, they are not following. I'll keep spending the time. It's not fixed. I'm okay with spending the time. My intention is to everybody has to follow it. That's the way it goes anyway.
Okay.
Yeah. Any other questions? Okay, I'm stopping the recording, guys. So